Hi everyone. So I welcome you all to a new session that is continuation of our numbers module. And the first topic that we had done last time was classification of numbers. So let's talk about the next idea, that is divisibility of numbers. In this particular topic, what we are going to learn is the different divisibility and the remainder tests. And then there will be few more concepts related to special cases of divisibility, etc., etc. And then obviously in the end part we are going to solve few questions to understand the concept and their applications. So let's begin with the idea. So let's first introduce the terms which probably you all are must be aware, but just a quick recap kind of thing. So let's take a number, for example 19, and let's say this 19 is divided by, let's say, 5, for example. So if we do the normal division that we know from the school days, we can say that 5 threes are 15, and then remainder becomes 4, for example. So let's define the terms one more time. So 19 is the dividend, for example. Then 5 becomes your divisor. Then 3 becomes your quotient, and 4 becomes your remainder. So these are the terms. So the same number 19 can be also expressed as 5 threes are 15 plus 4. And if we simply substitute the terms in the place of the numbers, we get a simple relation, which is dividend is equal to divisor into quotient plus remainder. So that's the relationship that we need to remember. And again, as I said, probably you would know this from school days, but just a quick recap kind of a thing. So that's the terms, and that's the initial introduction to the idea. Now, as discussed, let's start with the divisibility tests. And for example, the first the group that we are about to study are going to be powers of 2, for example. So let's say the first power of 2 is 2 raised to 1, which is 2 only. So how do we decide whether a number is divisible by 2 or not? So very, very simple. You probably know this also. The number has to be a even number. Now, how do we come to know the number is even number? So the last digit has to be either 0 or 2468, for example. So if any of these conditions are satisfied, then automatically we say that the number is even number, and if the number is even number, it is divisible by 2, and we don't normally divide and check. And that's the whole important idea about divisibility test. The importance of tests is that you're not supposed to do the entire calculation, which is time consuming. You're supposed to do a small calculation, and just very quickly you can identify whether number is divisible or not divisible. Simple as that. Now, let's continue the sequence further. So, for example, the second power of 2, that is 2 ka square, which is 4, for example. So, how do we come to know is number is divisible by 4 or not? So, obviously, we have to check the last two digits of the number. So, if the last two digits of the number are divisible by 4, then we say that the number is also divisible by 4. If the last two digits are not divisible by 4, then the number is not divisible by 4. Or also, last two digits also can be double zeros for that matter. So that's the divisibility test of 4. Now, if we continue the same pattern, the next power of 2 is basically 2 cube, which is 8. And if you can understand the scenario, for 2, what we said is only the last digit is important. For 4, we said only last two digits are important. Why so? Because 2 is the first power of 2, 4 is the second power of 2. So hence we focused on last two digits, for example. So now 8 in this case is obviously the third power of 2, that is the cubic power of 2, and hence automatically we need to focus on the last three digits of the number. So if the last three digits of the number are divisible by 8, then we say that entire number is also divisible by 8. We do not have to check. And it can be also again three zeros in the end part of the number, basically. So that is divisibility of 8. Then similarly, divisibility of 16 can be, if you have guessed it right, 16 is 2 raised to 4. So obviously, last four digits should be divisible by 16 or four zeros. Then the entire number is also divisible by 16 in the same manner. So this is the way to do that. and this pattern can keep on continuing further and further. So for example, if someone asks what is the divisibility test of 32, so you need to understand 32 is 2 raised to 5, for example. So last 5 digits should be divisible by 32, then the number is also divisible by 32, and so on and so forth. So that's the whole idea, and this is the way you can remember it also. Now, going further, let's talk about remainder tests also. And again, the whole point of remainder test is that you understand things faster. Because again, if you remember, for normal division method, to get the remainder, you will get it at the very end part of the calculation of the division. So that will take a lot of time. So again, the whole aspect of test is you have to do some small calculation and you will be able to easily find out what is the remainder in that particular case, for example. So that's the idea. So let's continue that also. So for example, and the best part is, whatever is the divisibility test in 90-95% of the cases is gonna be the remainder test also. So there is no new thing or difference whatsoever in the processes. So for example, you want to find out what is the remainder if you divide a number by 2, let's say. So you're not supposed to divide the entire number, you are supposed to divide only the last digit of the number by 2, and whatever is the remainder that you get here will be the same remainder you will get in the end also. So you don't have to do any other calculation. Similarly, for 4, you are not supposed to divide the entire number by 4, but you are supposed to only divide the last two digits by 4 to find out the remainder. Similarly, for 8, you have to divide only the last three digits by 8, and lastly, for 16, you have to only divide last four digits by 16 to find out the remainder. So that's the calculation really, and this is the way you can look at all these numbers in this particular scenario. So these are the remainder tests for the powers of 2, for example. Now, if we continue this further, let's talk about the next group, or probably let's do a small question also so that you get the application. So, suppose this is the number and you want to find out what is the remainder when this number is divided by 4. Now, see, naturally, if you are doing this, what you would have done is you would have divided this number by 4 to find out the remainder, correct? So, 4 twos are 8, then 7 comes up, so 4 ones are 4. So 3 comes up 36, that is 9s are, then this is 0, then again 9, so 2s are 8, you get 1, then 2 again, so that is 3s are, then 3, so 0, then 37, so 9s are 36, so remainder is 1, then 2 again, so that is again 3s are, which is 12, then again 0, that is 1s are 4, that is. So all of this calculation gives me the answer as 2. This is the normal division method that you would do otherwise. But we have learned something amazing and powerful, which is the remainder test of 4. And we know now we don't have to divide the entire number by 4. Just now we saw we have to divide only the last two digits by 4 for the number. So let's apply that. So last two digits of the number is 26. So not going to divide the entire number. We are only going to divide 26 by 4. So 4 6 are 24, and voila, we get the remainder 2, the same remainder that we got here in the big calculation, in the long calculation. So see how much time this has taken, and how effortlessly, how easily you can do. Probably you can do it orally also if your numbers are good enough. So that's the whole benefit of remembering all these things, and I hope you have understood the power of this calculation. So that is the reason why you have to remember this. This has to be your motivation to remember such smart things, and not only remember but start using it in your calculation, because if you don't use it, then again there is no point learning something better. So remember that. Now, moving on, let's talk about the next thing, that is powers of 3. So there are different powers of 3. The process is same. So 3 raised to 1 is 3, Most of you probably know, but still I will do this. So if you want to find out what is a remainder, if a number is divided by 3, I simply have to add all the digits of the number. So if I add all the digits of the number and if the sum is divisible by 3, then I can say that the number is divisible by 3. If the sum is not divisible by 3, then the number is not divisible by 3. Simple as that. So let's take this as an example. If we add all the digits of this number, so 2 plus 1 is 3, 3 plus 7 is 10, 10 plus 3 is 13, 13 plus 6 is 19, and 19 plus 2 is 21. So sum of all the digits is 21, and we know as a matter of fact that 21 is divisible by 3, 7 threes are 21. So this entire number is also divisible by 3. So sum of all the digits should be divisible by 3. If that happens, then the number is divisible by 3. If that doesn't happen, then the number is not divisible by 3. So that's the test that you need to remember here. Similarly, the next power of 3 is 3 square, which is 9. What is the divisibility test for 9? Same picture. The sum of all the digits of the numbers should be divisible by 9. If that happens, then the number is divisible by 9. If that doesn't happen, then the number is not divisible by 9. So this example, this number we want to check. What we will do, we'll add all the digits. If we add all the digits, turns out the sum is 27 and 27 is divisible by 9. So the number is divisible by 9. Simple as that. So for all powers of 3, this is gonna be the pattern that you need to follow. So whether 27, whether 81, same story will continue every time. So this is also you can remember in groups, in bunches, what is a theme, what is a core theme behind each of the scenarios basically. Now, moving on, let's talk about the next one, that is the remainder tests for powers of 3. So the first power of 3 again is obviously 3 only. How do you find out a remainder if a number is divided by 3? Simply, you do not have to divide the entire number. You have to add all the digits of the number, and whatever is that sum should be divided by 3, and whatever is the remainder that you get here will be the same remainder that you get otherwise. And same happens for 9 also. You have to divide some of the digits by 9, and then you find out the remainder, which you will otherwise get if you divide the entire number by 9. So same story again repeating here as well. So that is about the group of 3. The next group that we have is the powers of 5, for example. So first power of 5, that is 5 raised to 1, which is 5 only. How do you come to know a number is divisible by 5? Simply, we know that already last digit has to be either 0 or 5. If the last digit of the number is 0 or 5, then we say that the entire number is divisible by 5. Similarly, 5 ka next power is 5 ka square, which is 25. So for 25, you have to check the last two digits of the number. So if the last two digits are divisible by 25 or double zero, then the number is also divisible by 25. If last two digits are not divisible by 25, then the number is not divisible by 25. Simple as that. So this is like powers of 2 wala pattern. So same thing is happening here also. So for 125, it should be last three digits. Why? Because 125 is 5 ka cube. So last three digits of the number should be divisible by 125. Then the then the number is also divisible by 125, and so on and so forth basically. So these are the ideas that you can remember. Same goes for the remainder tests. So you want to find out a remainder if a number is divided by 5. You do not have to divide the entire number. You have to only divide the last digit of the number. So if you divide last digit of the number by 5, you get the remainder. Similarly for 25, divide last two digits of the number by 25. And for 125, divide last three digits of the number by 125, and so on and so forth. This is the way to do that. So these are the divisibility and the remainder test for the powers of 5, for example. Now let's talk about the next one, that is divisibility of 11. Let's consider a number, for example. So this is the number we want to check whether it is divisible by 11 or not. The simplest way to do that is you have to add the alternate digits of the number, and you have to take that sum, and whatever is that sum, you have to take the positive difference of that, and that positive difference should be either 0 or multiple of 11. Again, probably sounds complicated, but it is not really. Let's add the alternate digits. When we do that, you will get two sets of the sums. So the first set is this one, that is 5, 3, and 4 alternate digits. 5, 3, and 4 is 8 plus 4, that is 12, for example. And the other alternate set is the other numbers that you are probably guessing it also, which is 7, 2, and 3. So 7, 2, and 3 is also 9 plus 3 is 12, for example. And now, since we have taken both the alternate digits ka sum, both the sets we have to take the positive difference, and that difference has to be either 0 or multiple of 11. So now you will see in this case the difference is 0, and that means the number is divisible by 11. If the difference is not 0 or not a multiple of 11, then the number is not divisible by 11. Simplest way to do that, basically. So this is how you can figure out the first scenario of divisibility of test of 11. So the official statement is the difference in the sum of even place digits and odd place digits. Now this even place digits and odd place digits, you can remember alternate place digits must be either 0 or multiple of 11. Must be either 0 or multiple of 11, then you say that the number is divisible by 11, and so on and so forth. Then similarly, there are certain numbers which have their different divisibility tests. They do not have their own divisibility test. So one of them is this test for numbers having co-prime factors. So let's say we want to verify if the number is divisible by 6 or not, for example. So again, 6 doesn't have its own divisibility test. So what we will have to do is we'll have to figure out that the co-prime factors of 6, which is 2 and 3, for example, and if the number is divisible by 2 and 3 both, then we can say that it is also divisible by 6. Then we can say for 12, so for 12 it should be divisible by 3 and 4 both, because 3 and 4 are the co-prime factors of the number, and not 2 and 6. Why? Because 2 and 6 are not co-prime. That is the reason why we are checking with 3 and 4. So that means in the similar way, you can also decide for certain numbers. So for example, I mean, you can figure out for certain numbers if you think in the right proposition. That is, let's say you want to check for 20. So 20 k co-prime factors will be 4 and 5. So if it is divisible by 4 and 5 both, then the number is also divisible by 20, and so on, so forth. So that is about this particular idea. So these are the concepts. There are few more extra things that are required, but we'll see them as and when is required when we discuss the questions, for example. So as of now, let's stick to the basic ideas. Whenever the extra part comes, I will definitely let you know. So let's start with the first question. This is the one. Again, I would request everybody to pause this video as of now, and for example, try this on your own, and then obviously look at the solution. Okay, so I hope you have tried this. Let's discuss the question, which says a number is divided in such a way that the divisor is 12 times the quotient. Okay, the divisor is 12 times the quotient. Now I do not know what is the value of quotient, so let me assume that as q, for example. Then they have said that 48 is the remainder, and the divisor is 5 times the remainder. Okay, so the same divisor which is 12 times the quotient is also 5 times the remainder. Then what is the dividend? Okay, fair enough. So we know the formula. Dividend is equal to divisor into quotient plus remainder, which is what we have studied earlier. But they have given the condition for the divisor, and this divisor they are saying is 12 times the quotient. I do not know the quotient, so I assumed it as q. And they also said that the divisor, the same divisor which is 12 times the quotient, is also 5 times the remainder. So because it's the same divisor, I'm equating both the equation. And I know the remainder ka value, which is 48, for example. So I can simply solve this now. So want to find out the quotient here. So it is 5 into 48 divided by 12. Now 12 fours are 48, 5 fours are 20. So I've got the value of quotient here, and that value of quotient is 20. Now to find out the dividend, this was the formula. Now in place of divisor, I have both the choices. Either I can do 12 times quotient, or I can do 5 times the remainder. Let me do 12 times quotient. It doesn't really matter which one you do. You'll get the same answer. So let's substitute all the values we got in quotient as 20. So 12 into 20 into 20 plus remainder, that is 48. So this becomes 20 ka square, which is 400. 400 into 12. 12 fours are 48. So 4800 plus 48. Obviously that gives us the answer as 4848, which is answer option 4. For example, the first one. Simple question, straightforward idea. You simply have to apply the idea and then solve. You'll get your answer. So that's the first one for you. Let's do question number second. For example, very important to understand the question, which will only happen when you read it properly and not rush through it. Which says all consecutive natural numbers starting from 1 are written side by side till we write 100 digits. Now this part is super important. 90% of the people make a mistake here. They take 100 numbers. They are not asking us to write 100 numbers, they are asking us to write 100 digits, for example. And then they're asking what is the remainder when this number is divided by 8. So for this we need to know the remainder test of 8, which we know already. Last three digits of the number have to be divided by 8 to get the remainder, for example. So that is the remainder test. But that means now the only focus that we need to have right now is what are the last three digits of that number, for example. So we need to find that out. So how do we do this? Let's look at the question one more time. Consecutive natural numbers starting from 1 are written side by side. So you have to write 1, 2, 3, 4, and so on and so forth. Now imagine you started writing this. When you have written till 1 to 9, the 9 numbers. Now these all are single digit numbers. So for writing one number, you are utilizing one digit. So for writing these 9 numbers, you have utilized 9 digits, for example. But what you end up observing is that the moment you write 10 besides 9 or 11 besides 10 and so on and so forth, you would realize that each of these number is a two digit number. 10 is a two digit number, 11 is a two digit number. So after 9, every number is going to be a two digit number. So that is the reason we need to understand now. So 1 to 9, 9 digits for every number, one digit, because numbers are only single digit. But 10 onwards, every number is a two digit number. So we have to write down 91 more digits. Now, how do we get the breakup of these 91 digits? So since every number is a two digit number, if we divide 91 by 2, we get 45 plus 1. So we can write 45 such numbers after 9, the two digit numbers, and one more digit, for example. That's the breakup of these 91 digits here. Basically, you need to understand such things. So 9 के बाद का 45th number is 54. So the moment we write, I mean, imagine you've went on writing, you kept on writing 10, 11, 12, 13, 14, and so on. You reach till 54. That is the 45th number after 9. But you need one more digit. So the next number after 54 is going to be 55. So the moment you write down the first 5 of 55, you are done with all the 100 digits, for example. And that is how you come to know that the last three digits of the number are 545. So the last three digits of your number are 545, and the divisibility test of 3 is, sorry, the divisibility test of 8 is last three digits have to be divisible by 8, for example. So last three digits have to be divisible by 8. That means the last three digits we have figured out, 545. So if you divide 545 by 8, you get the remainder as 1, for example. So if you divide 545 as 8, you get the remainder as 1. So this is the way to do that, basically. So you have to read the question properly. That is last three digits. And last three digits, how you gonna get? One more time. 1 to 9, 9 digits. Then 10 onwards, every number is a two-digit number. So we need to write 91 more digits because total 100 digits. That is gonna be the possibility by considering 45 numbers plus one digit. So 9 के बाद का 45th number is 54 plus one digit 55 का first 5, that is 5. So that is how 545 comes, and you divide that by 8, you get the remainder as 1. So answer is option 1, which is 1. Read one more time carefully to understand. Not 100 numbers, 100 digits they were asking. That's the second question. Let's look at the third one, which says all natural numbers from 1 to 100 are written side by side. Find the remainder when this number is divisible by 9. Now the question is different. Natural numbers from 1 to 100 are written side by side. So now we have to write all 100 numbers, and this becomes even more bigger number. I hope you understand that. And we have to find out the remainder when this is divided by 9. So for that we need to understand remainder test of 9, which is sum of all digits should be divisible by 9. I mean should be divided by 9. Then we get the remainder. Now this is where again a lot of people make a blunder. Sum of all the digits, people end up adding the numbers, and there is a huge difference there. You have to be super careful in such questions. Huh? The understanding has to be super great. So for example, uh, let's say you add numbers like, for you you know 62 and 63, the sum is 125 for the numbers, but we are not supposed to add the numbers. We are supposed to add the digits. The digits are going to be 6 plus 2 and 6 plus 3, which is far more different than 125. We're supposed to do this and not this. So first things first, if you're making that mistake, you're adding the numbers, then don't do that. That is not the right way. If possible, go back and look at the divisibility test, remainder test one more time. It says we are not supposed to add the numbers. We are supposed to add the digits of the numbers. So that possesses a new challenge to us. How do we find out so many digits ka sum? Now, again, for that you need to use the common sense a bit more, which is, imagine for writing the numbers 1 to 100, which digits are going to be utilized. So clearly same digits, that is 1 to 9. These 1 to 9 digits are going to be used again and again and again to write all the numbers. Only change that is going to happen is their place values are going to keep changing here and there. So that means we need to find out one simple observation first, which will act as a property eventually, that from 0 to 99, every digit is repeated how many times. So you can do this exercise. Again, I would request you to pause this video right now. Do this on your own. Try and find out from 0 to 99 how many times every digit is repeated. For example, 1 comes how many times, 2 comes how many times, 3 comes how many times, from 0 to 99. Okay. Okay, so assuming you have done this exercise and you have gotten some answers, so verify that. So the property is from 0 to 99, every digit is repeated 20 times, and you can check and re-verify if you have not gotten this answer clearly. So from 0 to 99, every digit is repeated 20 times. And we know 1 to 9, these are going to be the digits that are going to be used every time. So 1 to 9 ka sum jo hai, that is 45. And since every digit is going to be repeated 20 times, so we are going to do 45 into 20, which is 900, for example. But this 900 is the sum from 0 to 99 for all the digits, basically. But we are supposed to do till 100 because natural numbers from 1 to 100 are written side by side. So you have to add 100k digits also in this sum. So 100k digits is what? 1 plus 0 plus 0. So that is 1 only. So the total sum becomes 900 plus 1, which is 901, for example. Now what we have to do is we have to divide this 901 by 9, for example. And when we divide this 901 by 9, obviously we get the remainder as 1 again. So very, very different question where we were supposed to write down 100 numbers, but we were not supposed to add the numbers. We were supposed to add the digits of the number, basically. This is the way to do that. So what we did is from 0 to 99 every digit repeats 20 times, and 1 to 9 ka sum is 45, so 45 into 20 is 900. So this 900 is the sum from all the digits of the numbers from 0 to 99, but we were supposed to do till 100. So 100 के digits भी लेने पड़ेंगे इसमें. 100 के digits are 1 plus 0 plus 0, which is 1 only. So 900 plus 1 is 901, and if you divide that by 9, you get the remainder as 1 again, which is answer option 3 in this case, basically. So that's your third question, people, and this is how you can do it. Let's talk about the fourth one, which says which numbers should be added or subtracted from 39240 so as to make it divisible by 11. The best way to do this is use options only, and you will get your answer very, very quickly. So how do we do this? So first option, add 2 and subtract 9. So if we add 2 in 39240, the number becomes 39242. And if we subtract 9 from that, it becomes 39231. We have to check whether both these numbers are divisible by 11 or not. You can apply divisibility of 11 and you will realize they are not divisible by 11 straight away. And even if the first number is not divisible, you should not be checking for the second number because the entire option as a whole should be right. So even if the first one is not correct, don't bother checking the second one. Save time, move on to the next one. Second one, add 6, subtract 5. These are the numbers then, 39246 and 39235. Again, they are not divisible by 11. But if you do that for option 3, add 8 and subtract 3, that is 39248 and 39237, you would realize these are the numbers that are divisible by 11, for example. So that's your answer. That is answer option 3 for question number 4. And as I said, the easiest way to do that is by using options, for example. So that's the fourth one. Let's look at the fifth one, which says a number is divisible by both 36 and 10. Which of the following statements are false? Not true, huh? They are asking about false statements, so be careful about it. Now, how do we do this? Clearly, the best way to do this is assume a number which is divisible by both 36 and 10, and preferably the common multiple, that is LCM of both, which is 180. So 180 is our model number, and we have to check for 180 these statements. So the first statement is the number is divisible by 15. You check whether 180 is divisible by 15 or not. Then yes, it is divisible by 15. Similarly, the number is divisible by 45. Yes, 45 forza is 180. So number is divisible by 145 also. So this is also true statement. Third one, the number can be either odd or even. Now think about this. If a number is divisible by both 36 and 10, then it cannot be a odd number. It has to be a even number. So that means this one is the false statement. And then they are saying the number is always divisible by 75. We have to check 180 is divisible by 75. Clearly not. So this is also false statement. And they were asking the same, which are the false statements. The false statements are 3 and 4. And 3 and 4 is there in the answer option 5, for example. Answer option 5 is the answer for question number 5. Not true statements. True statements would have been answer option 1, which is 1 and 2 are both true. False is 3 and 4, which is so focus on such things also. Do not make a silliest of errors to get the wrong answer. Okay, let's look at question number 6 now after this, which says find the sum of P and Q in the given number if it is known that the number is divisible by 8 and also divisible by 9 and provided P and Q both are greater than 0. So here you can only solve this question if you know the divisibility of 8 and 9 very clearly. And let's first apply that. So divisibility of 8 we should begin with. So what is the divisibility test of 8? So the last three digits of the number should be divisible by 8. If I focus on the last three digits of the number, they are 9, 2 and Q. So what are the possibilities for that? So it can be either 920 or 928. There is no other number that is divisible by 8 otherwise. So, but they said that P and Q both are supposed to be greater than 0. So 920 is out. That means 928 is the number, which means Q is 8 for me, for example. This is how I figured out Q ka value from divisibility of 8. You can do that with trial and error. Some time is required for that. Now they also said that the number is also divisible by 9. Now what is the divisibility of 9? So we have to add all the digits. Okay. So we have to add all the digits and that should be divisible by 9, for example. So let's add all the digits. 7 plus 3, 13. 13 plus PP, I will keep it aside, we'll do it later. So 13 plus 4, that is 17. 17 plus 4, 21. 21 plus 9 is 30. 30 plus 2 is 32. And Q is 8. So 32 plus 8, that is 40. So this becomes 40 plus P should be divisible by 9. Obviously, only one possibility that it should be 45 because 45 is divisible by 9, which means P is 5. So now I've gotten P and Q both, and what are they asking? The sum of P and Q. So I have to add P and Q, which is 8 plus 5, which is 13 as the answer, which is answer option 5, for example. So easiest way to do that is you have to know divisibility of 8 and 9. Apply both. You get the values of P and Q and you get your answer. That's how you can do question number 6. I hope you are with me. You're understanding. If any doubt you have, any questions you have, go back to that particular question, see it again, feel that confidence, and then move forward. Now, let's look at question number 7, which says the difference between a two-digit number and a number obtained after interchanging the digits is 81. What is the difference between the two digits of the number? Now, this is the specific type. A difference between a two-digit number and a number obtained after interchanging the digits. So let's take a two-digit number as AB and number obtained after interchanging is BA. We have to take the difference. So let's consider the place values. It is 10A plus B and this is 10B plus A. We have to subtract them both. So if I subtract them both, what I will end up getting is 9 times a minus b is our difference, whereas their difference is 81. What are they asking? The difference between the digits of the number, that is a minus b ka value they want. So if I want to find out a minus b, this 9 goes on the other side, divides 81. 9 nines are 81. So I think a minus b is 9, which is answer option 5 straight away. You need to remember such situations, and that means what, going forward you can say ab minus b. If you do, the difference has to be straight away 9a minus b. You need to remember that as a special case of divisibility. A food for thought. What you should explore after this is, what happens if I do ab plus ba in the same manner. Do this and let us know what do you get as a answer. So that's question number 7. Let's talk about question number 8, which says, when a digit of a three-digit number are reversed, the value of the three-digit number reduces by 198. Okay, so this becomes what? Three-digit number general type ABC, reverse करने के बाद CBA, and the value reduces by 198. यानी difference is 198. Okay, their difference is 198. Let's explore for our case. So again, what you should be doing is three-digit number to place value 100A plus 10B plus C. This becomes 100C plus 10B plus A. We have to subtract them. If we subtract them, what happens is 10B gets cancelled plus minus. Then 100A minus A becomes 99A, and C minus 100C is 99A minus C, for example. So remember this again directly. If you do three-digit number and reversing and subtraction, the conclusion is straight away 99a minus c, which can be further broken as 11 into 9 also. So as a test, you can remember straight away, so that you don't have to do this every time going forward. Similarly, again, food for thought, same process. If you do ABC plus CBA, what do you get? Do this, do let us know. Now, coming back to our question, R99A minus C is 198. Okay, so A minus C is 198 divided by 99, which is obviously 2. So we have to find out sum of two numbers. Sorry, the difference between the two numbers have to be 2, and they both are single digit numbers. How many possibilities do we have? Again, you should list it down yourself, because that's an easy way to do that. So these are the 8 possibilities that are there for a minus c to be 2. 6 minus 4, 7 minus 5, 8 minus 6, etc., etc. Now, but they were asking about the number as a whole. Now, A minus C is 8, but the number has B also. And they have not spoken anything about repetition in the data. So, if nothing is mentioned, repetition is allowed by default. And B is a single digit number. So, how many values we can take with repetition being allowed? Obviously, all 10 values we can take, which is 0 to 9. So, B can take 10 different values, and A and C can take 8 different values. So, that means overall, if I want to find out how many values that the numbers have, so obviously 80 values that the number have. Why? Because B ke 10 values and A and C ke 8 values. So 10 into 8, that is 80 possibilities are there for the number. So answer option 4 for question number 8. So these are a few special cases of divisibility that I was referring to towards the end part of the concept, that you need to understand or remember rather, basically. Okay, now moving on, question number 9. Again, a superb type. A 6-digit number is formed by repeating 3-digit number. Okay, what can be the type? Let's explore that. So 3-digit number repeating and giving us 6-digit number. We can say ABC ABC. Now this ABC ABC can be further written as ABC triple zero plus ABC. Can take ABC common, and this becomes 1000 plus 1. Please don't make a mistake saying 000, otherwise it will be 0. So this becomes ABC into 1001, and this 1001 is multiplication of 7, 11, and 13. So what can we say? A, a similar 6-digit number which is formed after repeating 3 digits will always be divisible by all of them. The 3-digit number ABC, 7, 11, 13, and 1001 as well. That is what they're asking. The number is always divisible by what? So we got in that 7, 11, 13, and 1001, not this one. So that is answer option 1 as the answer. Do remember these cases. These are exclusive cases, but saves hell lot of time if you can do it correctly. One more time, food for thought. Explore this 4-digit number, 2 digits repeating. Okay, I will give you the type ABAB. In the similar manner, explore what you end up getting, and you will be surprised with the conclusion, because the number then you can say is of certain type, and that answer we have gotten as the answer for the first question. So you tell me what is the answer and what is the conclusion of this idea, if you have explored that. So that is your question number 9, which is answer option 1. Now imagine somebody doesn't know all these techniques. The worst part is you'll have to bloody check with every number and then get your answer, which takes so much of your time. So that is the whole idea behind these specialties and the special cases, so that you save a lot of time. But you have to remember that clearly by revising and practicing, and that is what your focus has to be. Okay, let's do the last one. It's a great question which says there is a number which after successively divided by 4, 3, and 8, successively is one after another, the division should happen back to back. The remainders obtained are 2, 2, and 5 respectively. What is the remainder when the same number is divided by 12 and 15 for that matter? So how do we do this? So to do this, the method is very, very simple, but we have to start from ulta. So the first thing was the number was divided by 8 in the last part, and the remainder that we gotten was 5. So we can consider any model number which will satisfy this property, and that model number is 5 itself. Why 5? Because if you divide 5 by 8, it is not divisible. You get the remainder as 5 only, which satisfies the case. A lot of people say 13. 13 is also a number, but 5 is the smallest number. We'll do for a couple of them so that you get the gist why we are doing what we are doing. So let's start with 5 first. So 5, if divided by 8, gives us a remainder 5. Then before 8, we were dividing by 3. So because we are going ulta, so you have to multiply by 3. And the remainder was 2 in that case. So we have to add that. So 5 3s are 15, 15 plus 2 is 17. 17 if we divide by 3, we'll get the remainder as 2. Yes, 3 5s are 15, remainder is 2. Correct. And before 3, we divided by 4 and we got the remainder 2. So because we are going ulta, we have to multiply. So 17 into 4 plus the remainder 2, which is 68 plus 2, which is 70. 70 if we divide by 4, yes, we'll get the remainder as 2. Why? Because 17 4 is 68, remainder is 2. So all these conditions are satisfied, which means the model number that we are talking about can be 70. And now what we have to find out, what is the remainder when this number is divided by 12 and 15. So let's do that. 70 divided by 12 and 70 divided by 15. What is the remainder in both cases? 12 5s are 60, remainder is 10. 15 4s are 60, remainder is also 10 in this scenario. There is this option 10 and 10, but then there are certain options cannot be determined. So this is what should provoke you to explore more, probe more, and understand more. Don't mark blindly answer option 2 because of this technicality, because of the options. So let's explore another possibility where the number need not to be 5 to begin with, because it's the smallest number that we had considered. The other number can be 13 also, because 13 if you divide by 8, 8 ones are 8, remainder you get as 5 for example. So let's start with 13 as a number. 13 when divided by 8 gives us the remainder 5. Then before 8 we were dividing by 3. So because we are going ulta, we have to multiply. So multiply by 3 and the remainder is 2. So that is 39 plus 2, that is 41. 41 divided by 3. Yes, remainder 2 आ जाएगा. 13 3s are 14. And उसके पहले we were dividing by 4. So we have to multiply again. So 41 4s are plus the remainder 2. So 41 4s are is 164. 164 plus 2 is 166 divided by 4. Remainder is 2, which is satisfied. So the other number that we have as a possibility can be 166 for example. So 166 if divided by 12, what is the remainder? And 166 if divided by 15, what will be the remainder? So 13 12s are 156, so remainder is 10. But 15 into 11 is 165, so remainder is 1 in this case. So here it is. Probably now you would have understood what is happening. So the point is when 70 was the number, in both cases we got remainder 10, but in 166 we got remainder 10 for 12, but we got remainder 1 for 15 ka scenario. So I think you probably would have guessed it. For 12 the answer satisfies every time the remainder 10, but for 15 the answer is not very sure. Sometimes 10, sometimes 1, I don't know. See, again you have to understand something. 13 is again a model number that we have assumed. It is not a compulsion that this was the number to begin with. It can be any other number also which satisfies that case, and I don't know if I do that calculation what answer I will get in the end part. So that is the reason. But these two examples or these two samples are sufficient for us to take that slight bit of risk. At least we are not making a blunder of marking answer option 2 from just one sample size. Here we have taken the second sample size, which gives us the answer as option 5, which is 10 and cannot be determined. This is how you can also follow that process. So hence I said very good question to end this idea, that is divisibility of numbers. So folks, do go through all of this one more time, and if you have any questions, do let us know. We'll be very happy to help you in any of the queries. So we are done with divisibility. Thank you so much. Have a great day. We'll meet again with the next